Today I have a little project that I've been working on for the past few days. It is a regression sort of program. It reads Excel data from down here. It loads it up into Python, and then it does 5 fits to the data. It does a linear, a quadratic, a cubic, a quartic, and a quintic fit to it. And then it outputs whatever it chooses to be best. It uses the SciPy library and the SciPy.interpolate function to do the fitting. It uses pandas to pull from Excel, and matplot to plot the PNGs on, and then fpdf to make the actual PDF output. Yeah, so this is for e to the x, and this is what it popped out. So it shows the linear regression and the residual. There are some errors when you get to really small residuals. We can look at that later, but that's pretty much when you really should only be using, say, like a cubic to look at the data, but you end up using like a quintic or something. But yeah, so you can see you go through, so the quadratic, it gets a little closer, cubic gets a little closer than that, quartic, then quintic, which is the last one, it shows, what it found to be the values for, or the coefficients, and that shows the residual plot, which is pretty sufficiently random, although you can see, the variation as it struggles to fit the line. So yeah, let's try it out with a few different things, and then, yeah, maybe I'll go through the code. This is actually the sign of x on here on the left. I didn't do any radians or anything. I want to see how it adjusts with the period. I think that'll be interesting. So we're going to save the Excel document, then we're going to run the program. Python's going to do its little bouncy thing down here in the corner, and then when that goes away, this will be updated. Okay, so let's go up to linear. Okay, so it looks pretty random. To be expected from, you can see the wave, start to happen. Quadratic, a little closer. Quartic is looking like the best approximation now, and then quintic gets a little closer. The residuals look pretty sufficiently random. I would say that this is a pretty good fit. For what I'll be using it for, which is, nothing too special. So yeah, maybe I'll try one more different type of function, and then we can see how it goes from there. Function, we have 4 times x to the 5th plus 3 times x to the 4th minus 2 times x squared minus 0.25 times x. So we're not going to do that. I copy that all down. We're going to save this, save the Excel document. We're going to run the program. Python's going to do its bounce. It's going to take a few seconds. Code's probably really unoptimized. And then it's done. We're going to refresh this. Okay, look at that. Looks pretty similar to the e to the x actually, but you can see quartic gets it actually very close. And then quintic. Okay, so we have 4, we have 3, pretty much 0, negative 2, 0.25, and then pretty much 0. So it does a very good job at approximating the functions. If we put them in like this, we could add a little bit of error to see how it handles, but I'm not sure that that's completely necessary. If we look at the residual plot, this is what I'm talking about. So theoretically they should be equally spread across the 0 so that the mean is in fact 0, but because the numbers are so small, I'm just going to disregard it. I don't think that it has very much sway on anything big. So yeah, maybe we'll try it out one more time with a little bit of randomness thrown in, and then I'll go through it is just y is equal to x plus 0.1 times a random integer. So we'll add a little bit of variation along the axis. So we save it, and then we run it. Python does its bounce, and then we are going to see that this is going to come out to looking like that. Not surprised. Pretty close to 1 for that. Looks like it actually tried to put a very slight quadratic fit on it, which is, I guess, residuals look pretty random, so it looks like it went straight through. yeah, so I'd say that's a success. I mean, especially just when you look at the data like that, you could probably pretty easily tell that you would want to put a linear fit on it. And then just even going as far as calculating like the R-squared and stuff, you could probably figure out that is the best thing, which this program does not do yet. But yeah, so that's a few different examples, and now real fast I'll go through the code. So this just imports all the functions. This reads the data from this Excel spreadsheet. This reads the X, and this reads the Y columns, and it sets them as arrays. And then I had to change the shape of the array because I was getting some mismatched dimensions. This goes through, it finds the maximums and the minimums and like the ranges between the data points, and basically just sets up all the stuff that's needed to format the graphs. This actually outputs an array for the fit, so this is where all the magic actually happens, and then everything else is just, analyzing that, putting it into a graph form. This actually does the linear regression for finding like these and printing them out. It's a whole little process there. This is my first time actually, or I guess my second time actually really coding something, so I don't know if this is the right process at all. I just sort of went through and I have no experience with any of this, so I just taught myself. But it goes through for each of the different types. Pretty much just the same process, just an extra variable each time. And then this is the PDF. It just makes a few pages, adds some cells with the values here, and then imports the images. It's pretty straightforward. It's 316 lines. I'm sure that you could get it down to probably 50, but I have no idea how. Thanks for stopping by. I hope this was interesting. Have a